Alright, so we've got Toolhead revision number 3. I made a little change to the toolhead, and I went with a 2-plate design. So I've got this bottom plate, which is 4 3/4 millimeters thick, and I have spread the carriage wider than this one. This one, the carriage sat just behind this heat sink, whereas this one is next to it. It's also moved further forward. I was trying to shift the center of mass around a little bit. I don't have it balanced. It's front heavy by about 20%. Left to right, it's pretty close. Maybe within 10%, something like that. Originally I had a 3-plate design where I had 2 3mm plates bolted together and 1 carriage bolted on the bottom and 1 carriage bolted on the top. The extruder was mounted here on top, and the Goliath was bolted to this top plate. And the Goliath is pretty long, so it's got quite a bit of a moment there. I really wanted to mount it to the bottom plate, but you would lose double the distance in Z travel by moving this down. Pretty much did that anyway with this, and the reason I went with this was for what I just mentioned about moving the carriages over to get a little bit more leverage on the cross, but also having one plate. I really only had to lap in the bottom plate and the bottom of this plate and the top of this plate in order to get these to sit flat. There's almost a mirror finish on the top there. I spent some time lapping that in to get that nice and flat. And then the top only has the one plate that's 3mm on here, and it's just really supporting the extruder. The tool board mount in the back here is bolted to this bottom plate, and then I still have to make one more little brace that goes from this plate to the back of this tool board, so it won't. It's got some wobble here back and forth. It's probably good enough like that. I do have the holes already in there for the bracket, I just haven't made it. So what's kind of good about this is if you wanted to go to a Bowden setup, God forbid, you could just remove this top plate entirely and put a connector in the top of this heat sink, and you could run a Bowden setup with it. So before, I had 2 3mm plates and 1 4 3/4mm plate on the top here. Weight wise, they're about the same. Even though I went to 2 plates versus 3, this plate is wider, so it weighs more, and so in the end this assembly weighs 289 grams minus the carriages, which are 50 a piece. If I went to a MGN 12C, I could probably get, I don't know, is it maybe 10 grams of carriage, something like that, but that's what I had, and so that's what I'm using. And before I had the tool board mount here connected right to the extruder, to the bolts here and here. There were standoffs on here that came out, and this was attached to it. So if you flex this, it would flex this extruder, which in turn would make this extruder flex, and then it would want to flex this plate. And so I ended up moving to a 4 3/4mm plate on this design just to make it a little bit more rigid. So this is what I've got now, and you can see down here I've got my bird air here, okay, and it is right down inside there. You can see the little nozzle there. And then the holes are slightly larger in these carriage blocks, and so to align this cross, you're gonna get your distance correct from here to here on the front and on the back, and then to get this 90 degrees, you just loosen up those 4 bolts in there and it'll twist a little bit. So we're going to see how this works out and test it for a while and see what it does, and see if it's better. Now, some of you that you heard of cross gantry, and you heard of core XY, and you heard of bed slinger, and why one versus the other. Well, this cross assembly here, this is a long moment that stops, well, it doesn't stop it, but it mitigates a lot of torsional rotation of this rail. And so each one of these backs the other from rotating. When you have a core XY, you have only one beam, and it wants to pivot about on the y-axis. That's why the y-axis never tests as good as the x-axis in a core XY machine. So this used to be a core XY machine, and with an unbacked rail, I could get about recommended 14,000 acceleration. X was, I believe, 33,000 recommended acceleration. I never could get any more than 14,000 acceleration recommended for y-axis with the setup here. When I switched to cross gantry, we're adding a whole nother rail here, but it makes everything more rigid. So the recommended acceleration for this machine is between 20 and 28,000 acceleration. So it's more rigid, and in my opinion, it prints better, faster with cross gantry. However, setting one of these up, it can be tough. I mean, you have to have these two at 90 degrees. You have to have all 4 of your top rails well aligned, well trammed to one another, or they're going to bind, or if you don't get them right, then you're going to have less recommended acceleration, more wear, more parts wearing out, and so forth. It's a lot tougher to set one of these up versus a core XY. But this tool head is stout. I mean, this thing is stout. It ain't want to move nowhere. Only movement you're seeing here is from the belt stretch. The motors are enabled now. This thing is stout. I'm doing this, the whole printer's moving. So it's just a very rigid setup. So anyway, we're going to try this setup here with the 2 plates, and see how that goes for a little while. And then well, if I like it, then we'll just keep it like that, and if not, I'll make another change. Anyway, so this is Frankenstein over and out.